Hello dear students, this is grade 11 mathematics lesson on unit 3 coordinate geometry. Today we will see equation of parabola. So after revising this lesson, you are expected to write equation of parabolas in standard form and draw the graph of parabolas. So let's continue to the lesson. Now let's see the definition of parabola. A parabola is the locus of points on a plane that have the same distance from a given point and a given line. The point is called focus and the line is called the directrix of the parabola. So here parabola is this a locus of point in a plane that have the same distance from a given point and a given line. So the point is called focus and the line is called directrix. This means look, parabola is this form. It's a locus of point that have at equal distance from a fixed point, we call this fixed point F, focus, and a fixed line, we call this directrix. So this means that if you take any arbitrary point on the line, the distance from focus to this point and the distance from the point to the line directrix and the distance from the point to the focus D2, these two are equal. This is the definition of parabola. It's a locus of a point which is at equal distance from the fixed point, focus, and a fixed line. So you have this one. Now let's see the terms here. This is a parabola and we have this line, this is directrix, this line, and focus, we have focus F here. So this is a locus of point which is at equal distance from this fixed point and this fixed line. So from this, the point F is this, the focus of the parabola, and the line, this fixed line is this, the directrix of the parabola. The line which passes through V and F and perpendicular to the directrix. A line passing through V and F, focus and vertex, perpendicular to directrix, we call this axis, the axis of the parabola. And the point V, this point V is this, the vertex which is found on the axis of the parabola. And the chord B prime which passes through the focus and perpendicular to the axis, we call it is the latus rectum of the parabola. And this distance, the distance from vertex to focus or vertex to directrix, we call this focal length and it's denoted by the letter P. Now let's see the standard equation of a parabola with vertex h, k and focal length P and its axis parallel to x-axis. Here the parabola has this form. Its axis is parallel to x-axis. The axis of this parabola passes through this. This is the axis. Its axis is parallel to x-axis. So its equation is standard form. The vertex is given h, k, and this one is the directrix of the parabola. And here we have focus, the focus F, and we know that the distance from vertex to focus is P, so we have the coordinate of focus. It moves P distance to the right. So here it is H plus P, K. In horizontal lines, the y coordinate does not change. but the x-coordinate changes. It moves by p distance, so you add p on h. This is it. And here, the directrix passes through this point. We can find this point. The distance from vertex to directrix also p. Therefore, the coordinate of this point is this h minus p. You move p distance to the left, so it is h minus p, comma k. So this is a vertical line. You can have this equation. It has x is equal to x coordinate. It is h minus p. So this will be the equation of directrix. So to write the equation of this parabola, you take arbitrary point on this parabola, and then the distance from the directrix to the point on the parabola is the same as the distance from the point to the vertex D2. So applying D1 is equals to D2, you can derive the equation of this parabola. Taking this point, we have this point, we can find this point. This point will be its coordinate is h minus p, and its y coordinate is, since this horizontal line, the same y. So the distance from this to this is the same as the distance from this point to the focus. Using that, you can derive the equation. Please refer how this equation of parabola is derived. So deriving this, you will arrive at this one. So you will have such form of equation, the equation of parabola with vertex h comma k and focal length p is given by this form. Y minus k is all squared is equal to 4p times x minus h if it opens to the right. If the parabola opens to the right, this becomes this positive 4p. If the parabola opens to the left, so the equation will be this y minus k is all squared is equal to negative 4p times x minus h if it opens to the left. So after this, by the way, draw the parabola and then determine everything you want. For example, if we have this parabola, y minus k is all squared is equal to negative 4p times x minus h, it opens to the left since this one is negative. So you draw, roughly sketch it, and take the vertex, put the vertex is x coordinates h, y coordinates k, h comma k, and draw the axis, and roughly put the directrix here. You can find the focus, this point. The focus moves p distance, so p distance to the left, this means h minus p. Y coordinate do not change since the line is horizontal, and this point, you can determine this point. The distance from vertex to directrix is p, so you move to the right, so you have this point to be this h plus p comma k. So since it's a vertical line, the equation of directrix will be this x is equal to this h plus p. We have this one h plus p. What else? We can also find the end points of this latus rectum. To find this, since it's a vertical line, the x coordinate do not change. You need to find y coordinate. Here also, you need to find y coordinate. How? You put h minus p on the equation, and then you find the coordinate y, or second coordinate. So this is it. Let's see another standard form of equation of parabola, axis parallel to y-axis. So the standard form of equation of parabola with vertex h comma k, focal length is p, and the axis parallel to y-axis is given by this equation. You can derive this. Please refer your text how this formula is derived. So it is x minus h whole squared is equal to 4p times y minus k if it opens upward. If it's open upward, this part becomes positive, and the equation is x minus h whole squared is equal to 4p times y minus k. If it opens downward, the equation will be x minus h whole squared is equal to minus. We have minus here. minus 4p times y minus k if it opens downward. So now let's see example. To write equation of parabola, we need two things. One is the vertex, the other is the focal length. And the third one, we need to see whether the parabola is its axis parallel to y-axis or x-axis. So after that, you can use the formula. So here it's asked, write the equation of parabola with vertex negative 2, 5 and focus negative 2, 8. So here we have the vertex. So we need to find what? The focal length and its axis, whether it opens up, down, to the left, to the right. So to see that, let's roughly sketch this parabola. Here the vertex is roughly sketching. Assume this point is negative 2, negative 8 and so on here. The vertex here we have maybe 1, 2, 3 and so on. So y coordinates up to negative 8. So here negative 2, assume this one is negative 8. So y coordinate moves up to 5. Assume this one is 2, 4, 6. So roughly sketching, negative 2, 5. Negative 2, 5 is this here. The vertex of our parabola is this at negative 2, 5. And the focus is at negative 2, 8. The focus is here. This is the focus. It is negative 2, negative 8. So the shape of the parabola will have this form. It's a vertex is this one and the focus is this one. So the parabola has this form, so it opens down. So from this I can find the distance from vertex to focus, this distance, it is p. So p is equal to this distance. Since it's a vertical line, you can take the difference between y coordinate. So 5 minus negative 8 is 5 plus 8 is 13. So p becomes 13, or p is 13. And then we write the equation. This is a parabola, its axis parallel to y-axis. So you have this form. The formula, it is x minus h the whole squared is equal to, since it opens down, you have negative here, negative 4p times y minus k. So from this, you have this one, x minus, our vertex is, the coordinate is minus 2, minus 2 is plus 2, x plus 2, the whole squared is equal to negative 4 times p is, we have found p to be 13 here. So 13 times y minus k. K is a vertex coordinate, y coordinate is 5, y minus 5. So multiplying this, you have this one, x plus 2 the whole squared is equal to negative 52 times this y minus 5. So this is just the equation of a parabola with vertex negative 2, 5 and focus minus 2, minus 8. Now let's proceed to the next example. Here it says, write the equation of parabola with vertex 4, 3 and passes through 5, 2 and its axis is parallel to y-axis. So to write the equation, we have to sketch roughly because we need to see whether it opens up or down since it is parallel to y-axis. So let's sketch roughly. Its vertex is 4, 3. Maybe let's take this to be 2, 4 and 6. Here also it is 2, 4 and 6. So the vertex is 4 comma 3. It's vertex 4 comma 3. We have 4 comma 3 here. Is this the vertex of the parabola? It is 4 comma 3. And it passes through 5 comma 2. 5 comma 2, here is 5 between 4 and 6. So it passes through this point. So as you can see, this is a vertex. The parabola is parallel to its axis, parallel to y-axis. The parabola have this form. Again, it opens down. So it passes through this point. This point is it's 5 comma 2. So we need to find P. We have vertex. We need to find P. To find P, write the equation first. It has this form. Since it is axis parallel to y-axis, it has this form. The equation x minus h the whole squared is equal to, it opens down, so you'll have negative here, minus 4p times y minus k. It will have this form. Since we have h and k, substitute h and k, so the equation have this form. X minus, our h is 4 here, the whole squared, this is equal to minus 4 minus 4p y minus k. K is T3. This is the equation, but we need to find P. To find P, since this parabola passes through the point 5 comma 2, you can put 5 in place of x, 2 in place of y, and then you can find the value of P. So you can put 5 here. It is 5 minus 2 the whole squared. This is equal to minus 4p times y is 2. It is 2 minus 3. 5 minus 2, 3. 3 squared, 9. 9 is equal to 2 minus 3 is minus 1. Minus 1 times minus 4 is this, positive 4p. So therefore, from this, you can find P. Divide both sides by 4. So dividing both sides by 4, P is equal to 9 over 4. So the equation will be this, x minus h is 4, x minus 4 the whole squared. This is equal to minus 4, P is this, 9 over 4 times y minus k, y minus 3, that means y minus 3. So this becomes this x minus 4 the whole square. This equal to, you can cancel 4, you have minus 9 times y minus 3. So this is the equation of the parabola with vertex 4 comma 3 pass through the point 5 comma 2 in this axis parallel to y axis. Now let's proceed to the third example. Okay, the third example here, given the equation of parabola y squared minus 6y plus 8x plus 25 is equal to 0. Then determine the vertex of the parabola, focal length, focus, axis of the parabola, equation of directrix, endpoints of lateral rectum, length of lateral rectum, in it says sketch the graph. So let's do this one. To do this, first I need to write this in standard form. So to write in standard form, y squared minus 6y plus 8x plus 25 is equal to 0. To write in standard form, apply completing square meter for this part, and you will have this one. This will be equal to y squared minus 6y plus add half of this one squared, So you add 9 plus 8x plus 25. This is equal to 0 plus 9. You need to add 9 here because we add 9 here. And this expression becomes this y minus 3, half of this middle term, y minus 3 the whole squared. This is equal to, shifting this to the other side, you will have minus 8x minus 25 and 9. It becomes minus 16. 9 minus 25. So you have this one, y minus 3 the whole squared gives you negative 8 into, you can factor negative 8 into x plus 2. X plus 2. So this becomes y minus 3 the whole squared is equal to minus 4 times 2 times x plus 2. So we have written the parabola in this standard form. So we need to find these points from this standard form of parabola. The first one is the vertex. The vertex is x coordinate opposite and y coordinate. The number near to x is positive 2, so it's vertex minus 2 comma minus 2 comma positive 3. The vertex is minus 2 comma positive 3. B, the focal length is p. The focal length p is this 2 here. It is minus 4p times x plus 2, or p is 2. So B, the focal length it is 2. C, to find the focus, we need to draw or sketch the graph of this parabola. The vertex is minus 2 comma 3, and it opens, this one is negative, it opens to the left, since this form has y minus 3 whole squared minus 4p times x minus h form. So it opens to the left with the vertex minus 2 comma 3. So you have this one. Minus 2, assume minus 2 is here and 3 here. So we have this point. It opens to the left. Assume this point is to be this. The vertex negative 2 comma 3. So the focus is, it is this point which moves p distance to the left. We know p is 2, so it moves 2 distance to the left. That means the focus is, it is y coordinate is the same as the vertex, but its x coordinate will be this minus 2 comma 3. Therefore the focus will be, it is negative 4 comma 3. Next, D, axis of the parabola. Axis of parabola is this line. It's a line, it's a horizontal line. Assume 3 is here. So the axis of a parabola is this one, this horizontal line passing through the vertex. So it passes through 3. Therefore its axis is the horizontal line y is equals to 3. Therefore its axis is y is equal to 3. Now E, equation of directrix. The directrix moves 2 units to the right because p is 2. Therefore the directrix will be at this point, moving 2 units to the right, or simply it is, you add minus 2 plus 2 comma 3. Therefore, this it is negative 2 plus 2 0, 0, 3. The equation that means the directrix passes through 0, 3 and it's a vertical line. It's a vertical line. Therefore, vertical line x is equals to 0 will be the equation of the directrix. Therefore, here equation of directrix will be this x equal to 0. What else? F, endpoints of latus rectum. To find the endpoints of latus rectum, here latus rectum passes through the focus. Its endpoints are on the parabola. Therefore, since it is a vertical line, the x coordinate is constant. We need to find y coordinate. The x coordinate is negative 4. Therefore, using the equation, this equation, y minus 3 whole squared is equal to negative 4p times x plus 2. Substituting the value of x negative 4, you'll have this one. Y minus 3 whole squared is equal to negative 8 times, we put negative 4 in place of x, negative 4 plus 2 is this minus 2. You have minus 2 here. Therefore, here y minus 3 the whole squared is equal to 16. When you multiply it, you get 16. Therefore, y minus 3 is equal to plus or minus 4 square root both sides. So, you have y is equal to 4 plus 3, it is 7, or y is equal to negative 4 plus 3. It becomes negative 4 plus 3, it is negative 4 plus 3 minus 1. Therefore, this minus 1. The endpoints of latus rectum will be, one point will be negative 4, 7, and the other point will be this negative 4, minus 1. Therefore, the endpoints of latus rectum is this. One endpoint is this negative 4, 7, and the other endpoint is this negative 4, minus 1. Okay, G, we are asked to find the length of latus rectum. The length of latus rectum, this length, so this distance, since it is a vertical line, x coordinate is constant, so you can take the difference between y coordinate. So 7 minus negative 1 gives you 8. So the distance between, or the length of latus rectum will be this 8. By the way, for any parabola, the length of latus rectum is always this 4 times p. You can see here 4 in absolute value, 4 times p only, or it's 4 times p. So we have p2, so 4 times 2 gives you 8. So the length of latus rectum is 8, or you can use 4 times p. To summarize what we have seen today, the standard form of equation of parabola with vertex h, k and focal length p and its axis parallel to x-axis is given by y minus k the whole squared is equal to 4p times x minus h if it opens to the right, and y minus k the whole squared is equal to negative 4p times x minus h if it opens to the left. The standard form of equation of parabola with vertex h, k, focal length p and its axis parallel to y-axis is given by x minus h whole squared is equal to 4p times y minus k if it opens upward, and x minus h the whole squared is equals to minus 4p times y minus k if it opens downward. And please read examples on page 87 to 92 and do exercise 3.4 on page 93. So this is all about today's lecture. Until next time, goodbye.